question 4. 1,000 people were at a concert. A random sample of 25 of them was selected, and the age of each person recorded. Here are the results. So display the data in a stem and leaf plot. Now the stem and leaf plot needs to be ordered from the lowest to the highest. So you can do it in a couple of ways. You see the 25 ages you have there. You can either rewrite them from the youngest age to the oldest age and keep any repeats together. Or the way I personally do it is I do out the stem and leaf and then I redo it in the right order. Okay? So your stem and leaf plot is as such. You draw a line. You have your tens on this side and your units on this side. If you're asked, say, the measurements of ants, like they were asked 1 year, where it's like 1.7, then you'll have your units on that side and your points, your decimals on the other side. Okay? So you have people in their teens, people in their 20s, and people in their 30s. So that you only write once. The 10s you only write once. That's your teens, your 20s, and your 30s. So on this side, you write the units. So 11, the units would be 1. 12, the unit would be 2. So on this side, you write the number that comes after the 10s. Okay? So in this case, first when you come across, you have 17-year-old, an 11-year-old, an 18-year-old, an 18-year-old, a 16-year-old, a 19-year-old, and a 13-year-old. In your 20s, you have a 25-year-old, 28-year-old, 27, 21, 29, 25, 27, 21, 23, 21, 23, 21, 24-year-old, 25-year-old, 22-year-old, and 28-year-old. In the 30s, you have a 35-year-old and a 31-year-old. Okay? Now that's what I do first. I just get them all down so I know what it is. And then I'm going to redo my stem and leaf and put them in the right order. Okay? So this is the proper one. My tens on this side, my units over here. So in my teens, in the correct order, I have one 11-year-old, one 13-year-old, one 16-year-old, one 17-year-old. I have two 18-year-olds, and I have one 19-year-old. I'm going to read all those much closer. 11, 13, 16, 17, and 18, and 19. Okay? In my, that's in the what, teens. In the 20s. Now keep them underneath. Okay? So in the 20s I have 4 21-year-olds. I have one 22-year-old. I have two 23-year-olds. I have one 24-year-old. I have 3 25-year-olds. I have 2 27-year-olds. I have 2 28-year-olds. And I have one 29-year-old. Okay? Then in the 30s, I have one 31-year-old and one 35-year-old. And that is your stem and leaf plot, ladies and gentlemen. Okay? It's a nice, easy question.
That's it?
That's it. Well, that's not the whole question. That's your stem and leaf plot done. Okay, so that's part A. Now B, what is the median age of the sample? The median means the middle number. Alright, so that's what you're looking for. You're looking for the middle. So it tells you there at the start you have 25. So to get the middle number, you do 25 divided by 2, and that will give you 12 and a half. So the middle number is the next whole number. So 12 and a half, the middle number is the 13th number. Right, so you have to count and find your 13th number. Do not count these numbers here, only the numbers to the right of the line. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's my 13th number. That's my median. Okay, so the median it's not 3. When you're rewriting it, now you put in that it's 23. The median age is 23. Remember, you're talking about age. If you just put down 3 as your answer, then you're saying the middle age of the people going is a 3-year-old. There isn't even one 3-year-old at the concert. Okay? So just be careful when you're writing your answers down that at this stage you read it properly. That number is 21. That number is 25. That number is 35. That number is 19. Just because it's a 9 on the end, it represents 19. Okay? Just be careful with that. Now, they haven't asked it here, but I've often seen them ask, what is the shape of your stem and leaf chart? Okay? The shape of your stem and leaf chart is that it has one mound, one kind of hill. If you were to draw a shape around it, okay, it should have one peak. I know they don't usually give one, they usually give 2 for that very reason. Okay, so you describe as having one mound. Often it'll have 2, so you'd say it'll have 2 mounds. Shapeless. 2 mounds are 2 peaks. 1 peak, 2 peaks, 3 peaks. Or you could say it has a peak and 2 dips. Right, but that's how you describe the shape of it. Next question they ask. Based on the sample, estimate the total number of people at the concert who were in their 30s. So to do this, you need to get what percentage of the sample were in their 30s. Alright? So I don't think we need the sample anymore. Just write that out. Leave the rough one up. There was 2 out of 25 in their 30s. So to turn that into percentage, multiply it by 100 and get 8%. Okay? Of the sample, 8% of the sample were in their 30s. So if you use that to estimate how many of the 1,000 were in their 30s, now you get 8% of the 1,000. So the 1,000 people who went to the concert, multiplied by 8%, and the answer that you'll get is that 80 people were in their 30s. Right? The last question is, explain why we cannot say for certain that exactly this many were in their 30s.
Because there's only a sample of 25 too.
Yeah, sample of only 25 out of 1,000. The sample is too small. The bigger the sample, the more accurate your answer. For example, if you did all 1,000 people at the concert, you'd know exactly how many people were in their 30s. If you did 900, you'd have a fairly accurate idea. If you did 500, you'd have about a half chance of getting it right. But the smaller your sample, the more inaccurate your results are going to be. Okay? So when it comes to statistics, small sample is going to be inaccurate. The bigger your sample, the more accurate your results. So the reason why you cannot say, I cannot say, oh yeah, there was a concert last night and exactly 80 of them were in their 30s. Because you could pick another 25 and they might all be in their 30s. And then you'd say, oh, 100%, 1,000 of them were in their 30s. Sample is too small and too varied, you can't say for sure.